I know. So you're wondering what happens. It's all very well and good if the pivots are non-zero. And I know it's been just a joy to see that happen. But it may be that they're zero sometimes. And so we can deal with this beautifully. We'll deal with it kind of basically to start with, and then there'll be a more and more complete picture as things arise. In fact, we're completely happy about this. I think it's sometimes laid out that it's a problem or a disaster or a breakdown, but actually it's fine, right? So it's a very meaningful kind of thing. Okay, so let's lay out a couple of examples. So given this equation, this is going to be a short thing. We're just going to do two 2x2 systems. All right, so we've got these characters. All right, so there's row 1 and row 2. And let's put it into augmented matrix form because we love, that's very nice and tidy. We should be on top of that. We're always still really just playing around with equations, but this is the equivalent. So if we look at either of these, you can see that the x side of the thing is really just a multiple, right? So there's a -1 factor there. And if you think about that, right, you multiply that second equation by -1, you've got -x1 plus x2, right, across here, and then -5. These two equations then don't work, they're parallel. So this is just sort of by inspection. We wouldn't see this for a much more complicated thing with many, many equations, but so we can see something bad is going to happen. So let's see how it manifests. So we do the right thing. A nice tilde, yes, a little bit of flourish there. Row 2 prime, so we're trying to introduce a 0 here. We're trying to make a little upper triangular matrix. It's 2x2, there's only one entry to mess with. So it's always the new row 2 is the old one minus something times, in this case, row 1, because we're working on column 1. This is, as usual, this is L21, right? 2 is for the row that's being affected, row 1 is the one that's doing it. And on the bottom, I should have, it's always like this, on the bottom will be the first pivot. It's the pivot corresponding to the row that's doing the work, if you like. Okay, so that's a -1. Right, first pivot is always just sitting there as long as it's not 0. -1. And we have a +1 in here. All right, so you have to be, they're always -1s, +1s. So there's a +1 there. Okay? Right, so that's good. So let's see what happens. We know what happens, but let's see what happens. We are only changing, so this system is equivalent to this other system. It's not equal to. That's, again, this means has same solutions as. Same solutions as. This big tilde thing. Right, so we're not changing the first row, but we're basically adding, if these minuses cancel out, we're adding the first row to the second row. So that's easy, 0, 0, 6. Right, so this is a case where there's a 0 pivot. Pivot, and we say a pivot is missing. There's nothing to grab hold of, right? Pivoting, like in a sport or something, is something to, there's a point at which you can turn around. We can't do that. We couldn't use this, some multiple of this 0 to get rid of that 1, for example, right? We'd like to do that. And if it was a bigger matrix, we'd like to be able to use this pivot in the second column to wipe out all the other numbers, eliminate them. Okay, so it's bad, and it's bad because there's a 6 here, because if we go back out to the equations, we have, so row 2 now, again, dropping the prime, we don't keep primes, is really 0x1 plus 0x2 equals 6, or 0 equals 6. Not true. So there's no solution. So what that means is there's no solution. There's no solution. And these two equations, they ships in the night, right? They don't hit each other. They're parallel. that's the line version. Let's look at so the column picture. We should do that. The column picture is that, let's get the right thing. So this is minus 1, 1, and then plus x2 times 1 minus 1 equals 1, 5. That's what we're trying to do. And if we draw that picture, right, so 1, 5 is up here. This is x1. Sorry. That's important. The column picture is in y space, which we'll get to later on, y2. So this is b. Let's call this b, right? This is our b vector. This is 1, 5. Yep. And we're trying to add some multiple of minus 1, 1, and some multiple of 1, minus 1 to get that. And so, but minus 1, 1 is pointing out in this direction. Nope. Minus 1, 1 is pointing out in this direction. This is vector A, this is vector B, and so that's a 1, that's a minus 1, this is, and this is minus 1, and this is 1. This is A2, this is A1. There's no way, so we can't add multiples of these guys, right? So all we can do if we add multiples of these guys to each other is trace out, and what I'll do, we can only trace out this line here. We can only get to points on that line. Right? So, so there's no solution in this case. If B was a point on this line, we could do it, and there would be infinitely many ways to do it. So we'll come to that in a second. So hopefully that makes sense. So we'll say that this is there's a term we need to add here, and I guess I should have. Let me put it back at the top. So our menu. So singular systems. So this is a singular system. So sort of an archaic kind of term. So singular means odd or peculiar, right? Or as in rather individual. So sort of a singular chap, for example. So this so this is a example of a singular system. And this means there's no, so it's a system that doesn't have unique solutions. It doesn't have a single solution. So no unique solutions. And it may have 0 or infinitely many. Right, we're really going to understand this very well. One thing else that I want to say here is this gray line here, right, this thing. So that's a line in 2 dimensions. So we'll see that later on it's a subspace, right? So that the possible places that B can live, such that there's a solution, is a subspace. And we will call it column space. There's going to be a row space. There's going to be a null space. And there's going to be the rather curious left null space. But that's good. And you'll find out why you want to have a small left null space as a person. All right. Okay. So my left null space is small and yours is a form of abuse. All right, let's see. So, okay, so that sort of thing can happen again in a bigger matrix. You see this sort of thing. So you just sort of stop. There's no solution in this case. We could, however, have something like, let's say, different example. Right, so there's no way to make this. So then we'll call this example 1, and this is example 2. Let's go straight to the column. Well, I won't do it. I'll just give you I'll do the same format. Minus x1 plus x2, 2x1 minus 2x2 equals minus 2, and this one is equal to 1. So you can see that if you multiply this by the row 1 by minus 2, and of course it's much more complicated potentially. Row 1 by, what's up with that? Row 1, sorry. So this is row 1, this is row 2. If you multiply row 1 by minus 2, you get row 2. So they're the same equation. Actually, the same equation. So let's just see how that works out. Again, 3 by 3s, more complicated things. 4 by 4s, larger things. It will happen in more intricate ways. But this is just an intro story. And there's a very important thing I want to introduce here. So the augmented matrix version, boom, boom, great. 1 minus 2. It's always good practice to do these things. So same formalism as ever. So it's row 2 prime. It's going to be the old row 2 minus some multiple of row 1. Just want to do this over and over. I've jumped. Okay. This is good. We've got this guy. So this is going to be the pivot. Pivot is on the bottom. That's D1. This whole thing is L21. And so it's going to be 2 divided by minus 1 is really the structure of it. Right, so that's minus 2. Okay, so we do it. Right, this system is equivalent to this system in terms of solutions. That's a different set of lines. Top is the same. So we're just multiplying the top by 2, just as we said we would, but you know, our little formalism gives us that, and adding it to the second equation, and we get 0, 0, 0. So what's up with this? All right, well, let's back. So the equations, minus x1 plus x2 equals 1. Right, we're just reading off the top line there. And then the second one is 0 equals 0 equals 0. Right, so this is row now, row 2. So this one doesn't write the second equation. That's all good. So that doesn't tell us anything. I mean, it does in the sense that we know there's some redundancy going. So this but we wipe it out. So we're left with an equation. In fact, it's the line. So the two lines we started with, they are the same line. So they match everywhere. So these two equations are true at infinitely many points. For the column picture, we'll look at it. So let's see the column picture. What I wanted to say now is that we'll get to this elaborate. So this is later. This would be a pivot variable because it's connected to a healthy pivot, and this would be a free variable. Right, because there's no pivot, there's a 0 pivot in the second column. So there's nothing that constrains x2. I mean, obviously we could choose one or the other, but we're going to let x2 be anything we want. And the way to write that down is x2 is element of the real numbers. You know, I need to write that in a better way. Okay, so I'm going to write it as a sort of a calligraph. So these are real numbers. It's free, right? In the Mel Gibson sense. It can do whatever it wants. Right, so, okay, but that then constrains, so x1 is now constrained, now depends on x2. So we're going to let this be true, and this is structurally just going to be nice for us later on. So minus x1 equals 1 minus x2, right? Just unwrapping this equation up here, yes? And then x1 is equal to x2 minus 1. So you choose x2, you get x1. And the way to then go forward with this is you replace x as our solution. We always do this. Let me put a little thing. Again, this is foreshadowing. Replace pivot variables, replave, which is something Igor does for his master to something involving crucibles. So replace the pivot, so there could be many pivot variables with free variables. Right, the expressions in free variables. just say free variables. All right, a little bit more, there's some more words, but let's do that. So x1, so it's x2 minus 1, and x2, as we said, is free. It can be whatever it wants. And then we can break this apart. This is x2 times, so we just take all the x2s, and there's a 1, 1, plus there's a constant term, minus 1, 0. So if you go backwards with this, x2 times 1, minus 1, that's this term. x2 times 1 plus 0, that's this term. So this is something we see over and over again, right? If we do the column picture, here's our solution. There's a fixed, maybe I'm getting ahead, but this is fun. This is fixed, some fixed vector. It's an important one. And then this is something that moves around on top, right? So this is sort of a dialable piece. The one on the right is very important, right? So the fixed one is very important. Okay, so let's just look at the picture again, the column picture. Let's pull it out. The column picture, just to get some intuition at the end of this little calculation. So it's x1 minus 1, just returning to the start of the problem, plus x2, 1 minus 2, and we wanted that to equal 1 minus 2. Well, you can see how you could do it pretty easily, right? So you could say 0 and 1. That would work because these two match up, or minus 1 and 0. Now, the thing is, there are infinitely many solutions. Right, that's what this result was, x2. So you'd say up here where x2 is an element of the real numbers. Right, so that's our solution here. This is our full solution. X equals some fixed one plus some multiple of this thing. Okay, so let's leave it there. All right, so this is true. So just what's the picture for this thing again? So again, it's in the y1, y2 space. And we have minus 1 with a 2. Right, so this is A1, A2, there's A1, and A2 is just pointing in the opposite direction. And in this case, we had a B, this is B, which is 1 minus 2, so it's pointing down here as well. So this is B. So the reason we could, and if I can just maybe complete this in some way, so we could get any vector that lies along this line, right? Any B on this line will work. But if we have a B off here, no solution. So again, a singular matrix, it's a singular matrix. It doesn't have a full set of pivots, just like the other one. With the B that we had a solution. It's possible we could start with a B, and there are infinitely many, for which there's no solution. So this is the kernel of a lot more that's going to come along later on. There's really just 2 by 2s, but we need to be able to do it for larger and larger things. But that's really important, right? So there are these two things, 2 ways that once you have a singular matrix situation, you could have 0 solutions. You could have infinitely many. You will not have one. Very important. And we have a really nice little beautiful taxonomy that you probably, maybe you want a t-shirt, probably. We could make hats. Students usually demand these things, and I'm happy to oblige. So maybe custom ink or something like that. Posters, people will put them in their cars. Yeah. So, but that taxonomy is coming later on. So just keep the excitement under control, and we're good.